The power of flexibility. Introducing upgradable smart contracts. In the world of blockchain technology, smart contracts reign supreme. These digital agreements execute themselves, removing the need for intermediaries. However, traditional smart contracts have one limitation: immutability. Once deployed, their code remains fixed, making updates impossible. This is where upgradable smart contracts step in, offering a solution to this rigidity. Imagine a scenario where a bug is discovered in a deployed smart contract. In a traditional setup, fixing this bug would require deploying an entirely new contract and migrating all data. A costly and complex process. Upgradable smart contracts, on the other hand, allow developers to update the contract logic without redeployment. This is made possible by separating the contract's logic from its data storage. A proxy contract acts as an intermediary, interacting with users and routing function calls to a separate implementation contract. The implementation contract holds the actual logic of the smart contract. The beauty of this system is that the proxy contract, which users interact with, remains unchanged. When an upgrade is needed, a new implementation contract is deployed, and the proxy is simply pointed to this new version. This allows for seamless upgrades without disrupting the existing user base or data.
For this tutorial, we'll use Hardhat as our development environment, along with OpenZeppelin's upgradable plugins. Let's start by installing the required packages. Next, we'll create our initial contract num1, which will allow us to store and retrieve a number. Here's the code for num1.sol. With this contract, we can update and retrieve a number. But remember, we'll make this contract upgradable. To deploy our num1 contract in an upgradable way, we'll use OpenZeppelin's deploy proxy function. Here's our deployment script, num1 script.js. This script deploys num1 as an upgradable contract and initializes it with a value of 12. To connect Hardhat to a test network, like the Conflux eSpace Testnet, we need to update the hardhat.config.js file. Here's what it should look like. With this configuration, we're ready to deploy our contract to Conflux Testnet. Now that num1 is deployed, let's test it using the Hardhat local console. First, create an instance for num1 and attach it to the deployed address. Then, retrieve the stored number using the get function. Let's create a new version of our contract, num2, with an added increment function. Here's the code for num2.sol. With num2, we've added an inc function to increase the stored number by 1. To upgrade our deployed contract to num2, we'll use OpenZeppelin's upgrade proxy function. Here's the upgrade script, upgrade, num1.js. This script upgrades num1 to num2, adding the increment functionality without affecting the stored data. Let's return to the Hardhat console to test our upgraded contract. Create an instance for num2 and attach it to the deployed address. Now, retrieve the current number, which should still be 12. Let's call the increment function and retrieve the updated number. This shows that our contract has successfully upgraded from num1 to num2 without losing any data. The number went from 12 to 13 after calling the increment function. Conclusion. And that's it. We successfully deployed and upgraded a smart contract using Hardhat and OpenZeppelin. We preserved our data and added new functionality, showcasing the power of upgradable contracts. If this tutorial helped you, please like, subscribe, and share. Leave any questions in the comments, and I'll see you in the next video.